Hi everyone. So our team have chosen case study 3 and we name it as Aegis-Drone. We're gonna present it now. And these are our team members. We name it as Imperium. We are consisting of 4 people. So we have decided to choose case study 3, which is the first responder of the future decentralized swarm intelligence. So the reason we choose this case study because the first one is it will be producing high stake impact. The second one, swarm intelligence innovation. The third one, edge computing challenge. And the fourth one, Asian challenge. All of these reasons combined because we want to make our environment better. It's more convenient, and if there is disaster, we will solve it efficiently. And here is it, our solution, Aegis Drone.
Our solution, Aegis Drone, is a web app platform that coordinates multiple drones to scan disaster zones quickly and efficiently. Instead of relying on a single drone or manual search, rescue teams can deploy a swarm of drones that work together to map the area and locate survivors in real time.
Hello everyone, welcome to the demonstration for our proposed solution called Aegis Drone. It is an autonomous swarm intelligence for disaster response. This web application is able to detect survivors, coordinate rescue drones, and also restore hope even when communication infrastructure fails. It can coordinate over 10 active drones, and it has a 99% success rate and 24/7 deployment hours. And we have two options here to go to drone contributor page and command center page. So let's first go to drone contributor page. It is where you can register your drones, like we have here UAV001, and we can give it name as Phoenix, and also we have to enter the battery level for it, like 97 or something, and just register it. Okay, then it says drone registration successful, then we go okay and back to home. And then we go to command center and we can select the disaster type like earthquake or flood, wildfire, building collapse, and also hurricane. And then we go to try flood, and location we put it as Kelantan, and severity level we put it as high, and affected area like 15 or something. Then situation report like critical help needed. Then we initialize our mission, then we go to the simulation area. First thing first we can see is tick, which is the tick time, and the drones deployed 4 as the default value, and the elapsed time is the time for our simulation. And then we can see the indicator here, which is white for the place that we haven't explored yet, and the blue when the drones gone through the grid, it will turn to blue, and when the survivor, it will turn into something like in pink color, indicate that the survivor is detected. And this is the obstacles, like in the earthquake is the collapsed building, and heat or maybe muddy where the scanner will not work perfectly fine. And then we can see here all the cell scan, which is in here have 900 cells and 0 survivors found because we haven't started the simulation yet, and the coverage and the charging at base, because right now is 0 at base, because whenever the simulation is being played, the drones will use the battery and then later it have to charge. And then this is the config for our simulation parameters. Let's say we put 6 drones at first, and then grid we put it as 35, and obstacle we put 25. And the thermal noise is, you can detect the noises in the environment. This is the tick speed for the simulation speed. We put it as 200 for make it faster. And then we try to apply the simulation. You can see the grid for the simulation is getting bigger because right just now is 30 and right now is 40. And then we can see here the battery for every drones that we have. Like just now we put as 6, so there's 6 drones here. And then we can try to deploy the drones now. Okay, so now we pause. So this is our mission log. We can see that all of our drones get assigned to different sector, like 0 to 16 for the column and the row as 0 to 10. So this is the first drone sector, and this is the second sector, this is the third drone sector, fourth drone sector, fifth drone sector, and sixth drone sector. It will deploy to different sector to improve and maximize the efficiency. Then we continue. So we can see whenever they detect the survivors, it will turn to something like this. And also we can see the log in the mission log here. And then also after several tick, there will be like a analysis for some time. We can also add some drones during the simulation, like we have to add 2 right now. So whenever the drones is added into the simulation, it will reassign to different type of sector. Then we try to pause here, then we can see here. Whenever we add 2 more drones, it will reassign to different sector every time, because to enhance the efficiency. Then we continue, and we see. Okay, so we can see that drones become color orange because it needs to recharge. And also we can monitor every drones, like we can 007, and we can see the movement is being calculated, and the movement of every drone is using the breadth first search, meaning that we use AI for finding the best path that it will choose. And then we can see that whenever a sector is completed, like sector E is completed 100% coverage, all cells can, it will reassign to other sectors that need coverage, like here. UAV5 reassigned to sector F because it has a very low in the coverage, so it will have the sector F to complete its mission faster. And this is the thermal signature whenever a survivor is found. And then we can see here for the mission result as of now. So this is the situation whenever the mission is completed. All the drones will return to base and will indicate as the mission complete. So this is the result for the mission. You can try this simulation on your own with your own config and all in the link that I provided in the report.
So the technologies used for our solution. So as usual, it will consist of two ends, front end and back end. For front end, we usually use React app, which is a library to do the user interface, and the back end so that it will more into the simulation of the how the drones are going to work. The business model we made it consists of 6 parts. First part is who is our target users. So we have Agensi Pengurusan Bencana Negara from the government. The second one is the drone user. And the third one is SAR, people, search and rescue. What is the value in our project? The first one is overcome the human limit. Human limit like the eyesight, the ability to tell something weird. And then the second one is operator fatigue. When we, a human, do operation to find people in the disaster site, we are going to feel tired, but the machine doesn't. And the third one is real-time automated spotting. In our app, we can spot any weird things, people in real time. What is going to be our revenue? How we gonna get our money? So the first one is partnership with other companies. The second one is in-app shopping platform. And the third one is the advertisement and news collaboration. What does it cost to do this project? The first one is going to be model training. How we going to train our AI model to be good and efficient. The second one is the testing of the system itself. Of course, we're gonna spend it on some drones and some simulation how disasters really happen. And the third one is maintenance and operation. After it deploy, we're going to maintain it from time to time, and we need money for it. The market strategy, how we going to market this project into national and globally. The first one is going to be a partnership with DJI and Skydio. DJI and Skydio is a drone company, drone manufacturing company, and we're going to make our product more visible with them. And the second one, it will be boosting our visibility, which is industry conference and live demos. Industry conference usually comes national and globally. Now it's about scalability, how our product is going to grow and survive in the outside world. So we're going to implement new industry use cases in this project. We will adapt to other situations also. And then the second one, this project will be high demand because global weather are worrying and it will be worse from time to time.
Our solution is designed for organizations involved in disaster response. This includes disaster management agencies, search and rescue teams, and NGOs operating in disaster zones. These groups need faster and more efficient tools to locate victims and coordinate rescue missions. Traditional rescue operations often rely on manual ground search teams, single drone monitoring, and limited coordination tools. Because of this, search speed is slow and the area coverage is limited, which can also increase risk for rescue team. However, our Aegis drone solution solves this problem by coordinating multiple drones to work together. This allows faster search operations, wider area coverage, higher automation, and safer conditions for rescue teams. In the future, we plan to improve our system by building a real-time drone data pipeline to process drone data faster and more efficiently. We also aim to collaborate with leading drone companies to enhance drone capabilities and reliability. Another improvement is integrating our platform with existing emergency response system to support faster coordination during disasters. Ultimately, our goal is to expand this solution globally to support disaster response efforts worldwide. Aegis drone provide a smarter and faster approach to disaster response. By coordinating multiple drones, our system can cover larger areas, reduce search time, and improve safety for rescue teams. With real-time monitoring and scalable technology, the solution has the potential to support disaster response efforts not only locally but also globally.